Okay, I don't know why my board is deciding not to work. We have an x plus 2 and a 3x minus 1. Okay. So what we have here is we've taken this polynomial, used synthetic division to pull out a factor, or a linear factor, x minus 3, and then use basic factoring methods for quadratics from last year. If we were to punch this in, a good test for this, just bring my calculator up. And quite frankly, it's one that I do regularly. If I want to test this, I will punch it in. X minus 3, 3x minus 1, x plus 2, and then we had 3x cubed. What was the second term? Yeah. And then third term? Plus 6, right? What's the last term? Plus 6. Now, if these two are correct, or if I've done my factoring correctly, when I graph the first one, there's my blue graph, and notice right over top of it is my red graph. So we have the same, we have factored it properly. We're writing the same equation in a different form. Now, what are the zeros of this polynomial? So I'm basically asking you, what makes this polynomial, and this guy up here, that's the way it's going to work. What's the zeros of this polynomial? What makes this guy equal to 0? Well, a 0 would be 3, 0 would be negative 2, and a 0 would be 1/3. So we've taken it from a general form to a factored form, and then, oh, if I plug in 3 here, it's going to be 0 times something times something. That's 0. If I plug in negative 2, it'll be something times 0 times something. So again, if I ask you for the zeros, you're going to have to factor and find what the what makes the factors within this guy 0. Now, what are the x-intercepts? Okay. Another way that it might be asked, same question, what are the x-intercepts? What are the zeros? What are the roots of the polynomial? They all mean the same thing. Okay. So again, we have that process. Now, the question that we have to ask is, how did I find x minus 3 as a 0? Okay, why did I say x minus 3 was a 0? Well, I knew it. I did the question up. But what happens when we end up not having that? Notice what we see here. Negative 3 times positive 2 times negative 1. That ends up to be that positive 6 that we have up here. Each one of these zeros, we have the 3, the negative 2, and the 1/3 are factors of 6, although we'll ignore the 1/3 for the negative 1/3, sorry, the positive 1/3 for the moment. 2 and 3 are factors of 6. I would have tested, if I had that in front of me, I would test 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. And if I didn't find a factor, Mr. Hobie made a mistake, or he's testing something else. Okay? And you can see that here. Here are the factors of a quadratic. -2 times 3 gets you to that +6. We have a cubic here, -1 times -1 times +5. Sorry, +1 times -1 times +5. Those zeros in here are all factors of that -5. We have -2, -4, -1, -1 again. They again are all factors of that +8. Okay. So the fact that the constant term are the zeros are always factors of that constant term. Now, what happens if I put a 2 in front of some of these things? That's a little bit different because there are other factors that we're going to have to look at, or other zeros that we're going to have to look at. So the integral zero theorem. If x minus a is a factor of polynomial with integral coefficients. So that means that these numbers are not fractions. Okay. If x minus a is a factor of the polynomial, then the zero of x minus a, which is a, is a factor of the constant term. Now that's always the case. Doesn't matter, as in this case we have a 2 in front of it, or in this case we have a 1 as our leading coefficient. All we have to know is what are the factors of this. Okay. What are the factors of the constant term that are going to give me zeros? Now, the possible zeros of this function are plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, plus or minus 4. Those are the possible zeros of this function. Sorry, those are the possible integral zeros. Because there are rational zeros, fractions that could be zeros of this function. We're only talking about the integers. Now, if I want you to list the factors, x minus 1, x plus 1, x minus 2, x plus 2, and so forth and so on. So those are the possible factors. Those are the ones that we want. We want to find one of those to be able to factor out my system. Okay. Same thing with this one. Our possible zeros are plus or minus 1, plus or minus 21, plus or minus 3, plus or minus 7. Those are the only factors you have of 21. So the factors for the polynomial So again, the zeros of the polynomial, the things, if I plug in one of these numbers into here, I'm going to get 0. Those are the only possible ones that are integers for this one. These are the factors that would correspond to those, right? positive 1 is a factor, is the 0 of x minus 1, and so forth. Now, use the factor theorem to determine two factors. Remember, the factor theorem states if you plug in one of these numbers to that polynomial and you get out 0, that is a 0 of that function. So I'm going to test p at 1. And I'm going to do that, I can't remember. Because I can't remember what my values are. I've got terrible memory right now. So, again, I'm going to test this using technology. I don't care what that number is because it's not right. 1 store into x, and then go grab your function. 1 is not a 0. So factor x minus 1 is not a factor. Minus 1 store into x. Okay, minus 1 is a factor. I said find 2. Notice I start with small numbers. Try 2 into x. Two doesn't work. So we had minus 1 and negative 2 were our two zeros. So we had p at 1 did not equal to 0. P at negative 1 did equal to 0. P at 2 did not equal to 0. P at negative 2 did equal to 0. So the factors that are going to go in are x plus 1 and x plus 2. Now I could find a third, but I couldn't find a fourth in this case. Please find which of these 8 possible zeros is a 0 of that polynomial, and what is the corresponding factor that goes with it. Now, I'm showing using the tech. You can do it without using the tech and just plug in 1 to see if it works out. So who has 1, 0 for this function? Correct? Okay, so r at -3 equals to 0. So x plus 3 factor. Sean, did you get another one? Or did r at 1 not work for you guys? Okay. It just, the reason why I don't ever go to 7. Like if I have to, I'll go to 7, but I start at 1, 3, and so forth. So those are two of them, and r at 7 would be a third one. And yes, I can factor this guy by just using the factor theorem and this integral theorem. Okay? But don't count on that happening in assignments. We're going to ask you to factor fully. Okay? So this is the same question. So we have 1, 0. We're going to factor that. We already done this. Find 1, 0, and therefore the factor using the integral zero theorem. We found 2 back here. We only needed to find one of these. Okay, it's a different question. So for this one, what are the possible factors for this guy? Well, we could have x minus 1, x plus 1, x minus 2, x plus 2, and so forth. Let's find one that actually works. I'm just going to plug it in my head. We have minus 7. Okay, so p at 1 does not work. Plugging in -1. -2 minus 9 is -11. Plus 7 plus 6. That doesn't work. That doesn't work. P at -1 is not equal to 0. Does P at 2 work? Yes? I'm done. I'm done with my factor theorem at this point. P at 2 works. Therefore, the factor that we're going to have is x minus 2. I'm going to do this one with long division, because some people like long division more than synthetic, and I'm perfectly happy with that. So long division, I need 2x squared here. on you guys for putting that negative sign there. 2x squared times 2x. 2x squared times negative 2 gives me my negative 4x squared. Subtract those. Bring down my 7. I'm going to put a negative 5 here. And then I have a negative 5x squared plus 10x. Subtract this, I end up with a negative 3. Bring down my 6. I'm sorry, I'm running out of space. And then I have my negative 3 here. And I end up with 0. So we knew that we were going to have a remainder of 0 because we did the factor theorem up top here. If you didn't get a remainder of 0, you made a little oops somewhere in your system. Now here, I'm just going to continue working down with this. We now have our polynomial. Written as a linear times a quadratic. Now I want to see what can I do with this quadratic? Well, I need to factor that quadratic also. And that factoring of the quadratic is two numbers that multiply to negative 6 and add to negative 5. Those ones are negative 6 and positive 1. Now in this case, what's common to x3? Take out a positive 1. And I don't care which order you write them in. Now, personally, I'm not going to do long division on this one. I will do synthetic division. It is significantly shorter, and it doesn't involve subtracting, where we can make mistakes. The subtracting puts in more common mistakes that we can make. So let's go back up to this one here. Factors of 36. There's lots of them. Let's start with 1. Does p at 1 work? Is it going to equal to 0? Nope. P at 1 does not work. Does p at negative 1 work? 1 minus 6 is 5, so 0 there. Negative, or p at negative 1 give me a 0 out. Again, don't care what actually it does give me out, as long as it doesn't give me 0. Does 2 work? 16 plus 48 is 64, plus 20 is 84, minus 84 minus 48. Okay, 2p at 2 works. Check my work and make sure that p at 2 gives me 0. Yes? Good. Again, the fact that I'm doing it in my head doesn't really matter. Now, hey, we ended up with the same factors before. Doesn't really matter, it just happened to work out that way. I'm going to do this one synthetic division. Again, bring down the 1 because we know x to the power, 1x to the power 4 divided by x is going to give me 1x to the power of 3. Add, 21, 42, add these together, we end up with a positive 18, which is a good thing because now we end up with a positive 36 here, and we end up with 0. So we are right now at x minus 2, x cubed plus 8x squared plus 21x plus 18. Oh. That's not, I can't factor that one. I don't know how to factor cubes. Okay, yes I do, but we don't in this case. Okay. So we have to restart. We could continue on with the factors of 36. Okay. We know since 1 was not a 0 of this function, 1 is no longer, is not a 0 of that one either. Either is -1. We could possibly try 2 again. But I want you guys to see if -2 works. You can go back and plug in -2 to this guy or to this cubic polynomial here. Definitely going to have to be a negative though. 8 plus 16 is -8 plus 16 is 8 plus minus 42. -36. -2 doesn't work. Does -2 work? Now, I'm not even going to try 3 because these are all positives. Try -3. Does it work? No. Okay, I'm going to jump up to 6 now. -6. Do we get anything? It's possible. Okay. Did anybody find a 0 for that yet? What's that? -3 did work? Yeah. Okay, that. All right, so now we know -3 does work. Good. This makes my life easier. What we have to do again is we have to take this guy and perform synthetic division again. 1, 8, 21, 18. Again, we're dividing by x plus 3 into an x cubed. I'm going to get x squared as my first term here, so the 1 comes down. So now we have our factors at x minus 2, x plus 3, x squared plus 5x plus 6. Why did 2 not work? Oh, we never tested -2, did we? Now we can just factor this, 2 numbers that multiply to 6 and add to 5. Those 2 numbers are x plus 2 and x plus 3. So we're just performing shortcut factoring on this quadratic. And you might see this or I would probably write this with that guy squared. So combining everything we've talked about the last couple days, find a factor by using this integral 0 theorem. What number goes into? Okay, what number is what is a nice integer that's a factor of the constant? Keep testing it until you find one that you know is a factor by giving you 8x, or sorry, when you evaluate at that number, you get 0. Then perform synthetic division, or long division, synthetic most likely. If you have an x cubed, as we did here, repeat. And if you end up, or even if x4, because I've never seen it on a diploma, but we can actually do 5th degree. Okay? I've actually done as a bonus question on an exam, factor x to the 10th. I won't do that to you guys, because it's just too many chances of making mistakes. But go from there. Now, a couple other things. What happens if I could not factor this? Okay? If this is not factorable, that would be your answer. Right? You would have a linear factor, 2 linear factors, and a quadratic factor. Okay? So if you can't factor it any further, then you are done. Okay? So are there any questions on this process? So I'd like you to do do 4A. I'll give you 2 minutes to do 4A. You're right. Do 4A and B, and we'll go over it when we get back. So, all we're talking about, what are the possible integral zeros? Factors of 16, plus or minus 1, plus or minus 16, plus or minus 2, plus or minus 8, plus or minus 4. Now, I could ask you for what are the possible factors of it, which just would be x minus 1, x plus 1, and so forth. Okay, over here, plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, plus or minus 4. I would like you to factor 5a and 5b fully. So that means right down to linear factors if you can get there. I believe linear factors are possible in this case. So first find which one is possible. Possible. Not what are. So these are all possible. So when they say possible, what do you test right now? Which one does you test? For which one? Or I'm done with drivers and like that. Factor with 1. Okay. So what's this? You have to have your factor. Your 0 was 1. Right? It's also a 0 of this final. You a font down instead of a long division. Both are okay. So 0, 0, -4 plus 0 is 4, right? Minus 0 that, minus 4. And that is factor.
Is this something?
The first guy is dividing x into x2. That first one. So we're writing that plus 2 over here. Is that our number? So then our factor is negative. So what you transfer by divided by 2 is actually divided by factor b plus 0. And divided by x minus 2. The apple to the right in this case is the main factor.
So this is,
So it would be yeah. As the x equal to negative 2. Or this would be x. Because what you've done here, that
that's what is one.
you add just one word. So that's it's another block, right? Yeah. The factor is that. So we have that 1 is 0 of this one. It's also 2 of this factor. It's put it 0, 0, 1. You guys both did talk about different factors. So dividing by f and x. So dividing f by x. So x b by x. So we're going to have one term of x. So x squared equals so 0 x. And then you have the factor of x squared.
Obviously, you can do the rest of B and C because that's going to be the homework. So, just here's these two here. Looking across the top, you've got x to the fourth plus 2x cubed minus 0. So you've got these here.
So you have one factor of x minus 1, x squared minus 2. This is the x squared. You know, we can multiply the negative 4 and a half. a suggestion for this?
Yeah.
X cubed plus X squared. Two numbers that multiply to 12, negative 12 and a half. Negative 4. It's 4 times negative 3 and multiply. Everybody does. Find another calculation. Every one, 2, negative 2. One distance. Hopefully, that is it, and you can work on it. Okay, hold on. We got X to the 4, X cubed, X and X. So the next one. Okay? That's why it actually turned out to be 0. That is not supposed to happen. You know, we can multiply the 1 and add the 1. Yeah, factor. It's used here on. Wondering why. Careful here because we're missing each other. But you don't have an X squared on it. You gotta put that in place. So, zero is extra factor. You let T add 1. That 0 is bring it down to 1. Sure. I have number 4, 2, and 10. So replace 4 with 1. No. That's the part of it. Okay, so one of these has to take the, so it's minus 2. That has to be minus 2. But I think we can take care of it. I want 45, and I want that many 45. Then you're one more after that. This guy here is going to factor this. You're doing it well. You know, let me do it well. Up here, factor this. What type of factor? Yes, that's correct, right? So what are the factors that you're going to? So, have you been a full factor? Same factor because you can't. One more factor different. This one is quadratic. So the only factor is one. You can have a quadratic factor. This one is there. So this one, I guess, is 0. You have to have fine. So what are the ones that you have? Yep. Now you can go back and plug it in up here too. Try -2 this one. But this one you need to type it down. So now plug it in. Still got this guy here. Try negative or try 1. Okay, sorry, try -1. Because it doesn't matter. You can either plug this guy in or you can use -1 doesn't work out with negative. So that means since -2 is a factor this, it's also going to factor following. X plus 2 is the factor, right? But you have to 2 for the -2. So you have a factor of x minus 1, and you also now you have a factor of x plus 2. But you see that it's 0. Cannot be factored. You don't need to multiply 1 by 1. This guy is going to be 1 less than where he's going. Because if I can x into x plus 2, I'm going to get an x cubed. So there's going to be x cubed plus 3x squared plus 3x plus 2. It's only 1 less than you started with. So everything, so this first guy will be x cubed. That's good. X cubed plus 3x squared. If I was to multiply this out, So now you're gonna have to do this again. See what number goes in, it has to be one, negative one, negative two. Because that's the only factor. Correct. What that is, we find out answer to this one. Because that is not factor. We'll show the system. It's not factor.